Welcome friends to my YouTube channel CyberiLabs, and in this video I am covering very important topic which is new in CCNA, and you will never get this lecture in any CCNA classes previously because I think 98% of CCNA classes doesn't include IP header in details. So my motive is to explain you guys about the IP header, which is very important, and the roles and responsibilities of all the fields of IP header. So let's start with the video. If you see with this IP header, okay, you can find this image on Google also. So this is a image of IP header and all the fields of IP header. So I will explain each field one by one. So if you see this first field, that is IP header, that defines your IP version. Wait a second guys, I need a marker for this, okay, so that I can highlight what I am exactly explaining you guys. So if you see first field, this is IP version. So this field defines you the version, which version of IP you are going to use. Is it version 4 or version 6? Alright, so version 4 or version 6, in this field you will get the value, and on the basis of value you will easily find out that which version this communication is supporting, whether we are using version 4 or version 6. Then header length. Header length is, you can say, from here to here. Now a trick is there, like if someone asks you what is default size of IP header, you can say 20 byte. What is the default size of IP header? 20 byte. But is it fixed? No, because it includes your option field, and the size of option field is 40 bytes, and it varies as per your requirement, how many options or which options you are using. Let's suppose if you are using multiple options and that consumes multiple options consumes a lot of bytes. Let's suppose if those options make you like 20 bytes more, then in that case you need to add this 20 byte into this, and this header length will become 20 plus 20, 40 bytes. You got it? Like if how many bytes you are consuming from the option build, that is also the part of your header length. So by default header length, that is minimum, that is 20 byte, and let's suppose 20 bytes from option, it becomes 40. So this information, so by looking into this header length, you can easily identify that whether you are using an option or not. Let's suppose if you are using 28, so minimum you know that is 20 byte, so 8 is more, it means that you are using 8 byte from option field. So this information you will find out in this field. Back to this other part of this field, IP header, that is type of services. Type of services basically responsible for the quality of service, or you can say class of services, like what sort of treatment you are using with this IP packet, like whether you are deploying some special feature with this IP packet. Let's suppose if this is a voice packet, okay, so voice packet doesn't need any delay, it has to be like in a second. So you are consuming like a lot of bandwidth for this. So let's suppose if you are treating spatially that IP packet, so if you are using advanced feature to this IP packet to provide quality of service, in that case that thing will be defined in type of service. Let's take an example. Let's suppose if you are bandwidth reservation, let's suppose bandwidth reservation is there, technically we call it CBWFQ, okay, class based weighted fair query. So if you are using this feature, and this feature must be defined in this field, okay. So if you are using bandwidth reservation, in that case you need to define that I am using a type of service feature, that is bandwidth reservation, here it is. So if you are using some special treatment with this IP packet, it has to be here in this field. Now total length. Total length is very simple, you know the header length. Header length is all about your this from here and including your option field, but your total length also includes data. In some book you will find out data, in some book they will call it datagram, and some book you will find out payload. So all these things, all the three keywords are same. So total length means your header size. Let's suppose your header size was 28 byte plus whatever the data is, whatever the end user traffic is. So let's suppose if end user data is 20 byte and 28 byte of your header size, then it will become 48 byte of IP packet. Alright, this is a example I am giving you guys. So let's suppose 20 bytes of data or datagram is there and 28 is your header size, where 20 bytes of your minimum size, 8 bytes of option field and 20 bytes of your data. In that case, this IP packet will become 48. That 48 byte of information will be here. Okay, now very important part, that is fragmentation. So as per networking fundamental, maximum transmission unit is 1500 byte. Maximum transmission unit is 1500 byte. It means that above this figure, you are not allowed to send any packet which is greater than 1500 byte. So in that case, if some information is of 5000 or 10,000, you need to fragment it into smaller fragments. Fragmentation is required, mandatory, because above 1500 that is not allowed. First thing. Second thing, this 1500 is customizable. This is default. You can customize it as per your requirement also. Let's suppose this is your core router, and on this core router on outgoing interface you are applying like only 500 bytes. So from your network to outside, only 500 bytes size of packet are allowed. Above this, fragmentation required. I am again repeating. Let's suppose on your core router you mention that 500 byte of packet size, that is your maximum transmission unit as per your requirement of your network. In that case, let's suppose if some user forwarding some 1000 bytes of information, in that case fragmentation will occur on outgoing interface of this router. Okay, so this is fragmentation. Now if fragmentation is going on, then this field are very important to understand. Why? See this. First is identification of fragment ID. Let's suppose 4500 byte of information is there and I'm using this default thing 1500 bytes. In that case I need three fragmented packets. Now from this source I am forwarding this three fragmented packets. Okay, so these all three fragmented packets need a unique ID. It's not like this you can assign any unique any ID. It must be unique ID so that this destination can put it into an order, because if they are in order, then only this information is meaningful. You got my point? Because let's suppose this is fragment 1, fragment 2, fragment 3. At destination also, this fragment must be first, second and third. It's not like 3, 1, 2, because this information, jumbled information, is unmeaningful for you guys. Okay, so if it is not in order, it is useless. So it must be in order at the destination. Once it received by the destination, it has to be in order, and for the order you need an identification to each fragment. So this fragment ID will provide a unique ID to each fragmented packet. Okay, now this R is reserved 0 or 1, and it's set to be 0. So this is reserved one, they are not in use, maybe for future it is reserved. Do not fragment. Okay, before do not fragment, I want to explain you guys fragment offset and more fragment. Why? I will tell you that. So let's suppose fragment offset. What's the use of fragment offset is, you need to understand only one thing about fragmentation first. First is it is used for reassembly, because this destination, let's suppose this is destination, and this destination is receiving multiple fragmented packets. Okay, and if this destination receiving some multiple fragmented packets, these multiple fragmented packets has to be reassembled in a proper order. Okay, so how this is possible? This is possible only with the help of fragment offset. So now how exactly this fragment offset works, that can only be explained if I will explain you guys how fragmentation actually works. For that maybe I will try to make separate video, but for this IP header explanation, for this particular field explanation, this is more than enough. First, that it is used by the destination for the reassembly purpose. And second thing, for the interview point of view, you must be aware about that. First fragment packet offset value always be 0. First fragment packet fragment offset value always be a 0. Okay, two things. First, it is used for assembly purpose by the destination so that we can reassemble them in a proper order to make it meaningful, and then your 0. First fragment packet fragment offset value will be 0. Then more fragment. More fragment, let's suppose this source and this destination. This source forwards a one fragment, fragment 1. Okay. Now how this destination came to know that this is a fragment packet or this is a complete packet? Is this a fragment packet or a complete packet? When this destination receives this IP packet and it look up this IP header, if this more fragment flag set to 1, if this more fragment value set to 1, this destination came to know that there is no need to process this packet because this is a part of some bigger packet. I need to wait for that and wait for one more fragment. Let's suppose fragment 2 also comes. Okay, in this fragment packet, second packet also more fragment flag set is to 1. Still this destination will wait for other fragmented packet. So last fragment of this one bigger packet, more fragment flag always set to 0. You got my point? If packet is fragmented, MF set to 1. If packet is not fragmented, it is completed, then in that case MF set to 0. Alright, now move to next one, which is very important. Do not fragment. So do not fragment, basically only two possible values are there, 0 and 1. If 1 is there, do not fragment, means fragmentation is not required. If it is set to 0, maybe fragment. So let's suppose this is one router, okay, and this is one router, and on this router outgoing interface, my value of fragment, my value of maximum transmission unit is 500 byte. Maximum transmission unit is 500 byte. Let's suppose from here you are forwarding a packet of 1000 byte. You are forwarding a packet of 1000 byte. See this, guys. So you are forwarding this, and let's suppose the bit is on 1. The bit is 1. Do not fragment bit is on. So don't fragment. If it is on, don't fragment. So you are forwarding this as it reaches to R2 on outgoing interface. This outgoing interface configured with the 500 bytes of information, that packet has to be of 500 byte, not more than that. From here, one error message of ICMP will be generated, that is with the type 3 code 0. Type 3 code 0, which suggests that fragmentation required. This information, type 3 code 0, says to this source fragmentation required. The packet you are forwarding is not as per the size of our outgoing interface. So please break down this packet as per this size, 500 byte. So this information will provided by this destination, this router outgoing interface, with the help of this error message of ICMP, that is type 3 code 0, where it says that fragmentation required. And once you are saying fragmentation required, you are also defining the size. On the basis of 500 byte, you need to fragment your packet. Then only you can reach it to your destination, whatever the destination you are trying to reach. Alright, so this is all about do not fragment. Back to header. Now this next field is TTL, time to live. Time to live basically defines your life of packet, life of your IP packet. Okay, as per networking fundamental, the maximum life, you can say, it is 255. It means that as per networking fundamental, let's suppose this is your source and this is your destination. This source and destination, the maximum hop between any source and destination is allowed only 255. Why I'm using a word hop? Why I'm using this word is hop. Hop is nothing. Hop, any L3 device, router or firewall, whatever, any L3 device we call it hop. So let's suppose this router, this source is behind this router R1, R2 and R3, okay, and this destination is connected over here. So when this source forwards a packet to this destination, the by default TTL value it will take 255. Once it reaches to this R1 and it crosses this router 1 to router 2, then this TTL value will be decremented by 1 and it becomes 254. As it reaches to this R2 and R2 to R3, this TTL value will be decremented by 1, so 253. Now this, if you see, once it passes through this hop, it decrements this value by 1. It decrements its value by 1. So if any packet moving from one source to destination and its TTL value reaches to 0, its TTL value reaches to 0, in that case again you will receive an error message of time exceeded, timeout, time exceeded. So by this error message you can easily identify that your destination is about 255 hop away. So as per networking fundamental, it is not possible to reach over there. Okay, so it should be within this range. Okay, see guys, I am using like some terms over here. For beginners it is not easy to understand, because IP header is something very advanced topic. So after finishing your CCNA also you can listen this video, okay, because there is limitation with this IP header. This is not possible for anyone to explain this IP header with those normal terms, because I need to use those technical terms which is mandatory for this IP header. Okay, so after completion of your CCNA course also you can revise this with this video, because after completion of CCNA you must be aware about what is hop, what is L3, what is life of packet, and all those ICMP messages. But for beginners, I can understand this is not possible to understand in one shot, especially this IP header, but it is very important. You must be aware about this. Okay guys, so I'm continuing my video. So check this out. Protocol is nothing. Over here you will find out the information about your upper layer protocol. See, this IP header, this is IP protocol, works at layer 3. For layer 4, layer 3. So for layer 4, which routing protocol you are using? Sorry, routing protocol as well as any protocol you are using, that information will be over here. Let's take an example. Let's suppose if you are using TCP. In that case, in this field you will find out the value 0x6 in hexadecimal format. Let's suppose if you are using UDP. In that case you will find out the value 0x11, that is 17. So those numbers of protocols are predefined. So with the help of those numbers it will convert it into binary, and that binary value of those numbers will be stored here, and with the help of those numbers we can easily identify that the upper layer protocol is this, and that. Alright, now header checksum. Header checksum is all about data integrity. It is responsible for the integrity. So if header checksum mismatches, destination will discard the packet. If this checksum value doesn't match with its own value, then in that case destination will discard the packet. If it is matches, then it will process the packet to the upper layer. Alright, source IP address, from where you are forwarding this packet. Destination IP address, where you are going to communicate. Option field. Now this option field has lot of information. It depends on you which option you are going to use. It depends again on the situation, in which situation you are, guys. Okay, so option field, I will try to explain you few important options. Again I am saying, for beginners it is not possible to understand those options. Maybe if after completion of CCNA, if he repeats this video, he can easily identify and click that what exactly I mean to say. So if this option field, if I say, there are a lot of options are there. End of option, no operation, security, timestamp, or you can say commercial security, and MTU probe, MTU reply, but I will explain you few more important like loose route, or you can say loose information. So if I say loose route, this information, this option field will be used when you are doing netting, network address translation. If you are translating your source IP to some public IP, okay, let's suppose if you are translating your private IP addresses into some public IP address, in that case you need a network address translation, so you can say you are using loose option. Okay, then your strict source route. Strict source route says that information about all the routes. Okay, let's suppose this is your router and all the possible destination routes exist on this router, so all the possible routes information will be recorded in this strict source route. Now record route, don't get confused guys, over here you are getting information about the routes. For record route, the information is about all the networks known to this router, all the network information, network IP. So let's suppose this is a router and behind this router 3 networks are there, 192.168.1.0, 2.0 and 3.0. These are the network IPs. Network IPs guys, not host IP. Record route consists of network IP, all the network IP known to your router or core router. These are the options, like these are the few options I discussed with you guys. So if you are using out of these options, that information will be stored in this option field, and especially in that particular option, and how many bytes you are consuming, that will be added into your default header size, that is 20 byte. So if you are consuming 20 byte more, in that case your header size is 40. If you are using whole 40 bytes of information of option field, in that case maximum size will be 20 plus 40 becomes 60. Alright guys, now data, I already discussed with you guys. Data is all about your datagram and payload, whatever the end user is forwarding you, whether it is video, audio, text or graphical, whatever the information this user or end user is forwarding to the destination, that will be over here, and that information or that sort of size of information will also be added into your header, and that will become your total length. So I hope guys this video is informative for you, and especially for your interview nowadays, because in interview nowadays they're gonna ask you about some field especially, and how this field of IP header exactly works. So please like, share and subscribe this video so that other can also use this video for their benefits. Okay, bye bye, take care.